Hello, everyone. Welcome to the Definitely Not Dying edition. If I cough and have to mute the microphone and miss it, I apologize. We're going to be resuming our coding project. I don't really know where we're going with it today. Objectives are uncertain, but we'll see where we end up. Now, before we get too much further, hello there, Mobdo. Welcome. Let's see, we've got Mason on the bed, we have Ember on the table, and we have the rest of them chowing down. You can see Sky doing his oddball eating pattern as he grabs a mouthful of kibble, then takes it maybe a foot away and crunches each one individually. The rest of them have no such limitations. Yes, hello, Ember. But hello, everyone. Hello. Again, apologies if I sound a little bit odd. Weather change and cough acting up. It do be like that. Oh. Hey there, that one. Welcome. We are just getting started. Very congested. Like I said, if I have to mute to... I hope I can mute in time if I start coughing. It doesn't sound pleasant. I will attempt to say key. But yeah, code-wise. So last time, let's see if we can keep one on camera. So last time we were attempting to get our avoidance flow generation in there. We're close, but the problem is that it is leeching performance to try to use the full pattern that we are. So like right here, we've got wall avoidance. What we were trying to do is make it so that the enemies don't stand on top of each other when they move. I feel that paired with the wall avoidance will get us enough of the basic movement for enemies. And in order to accomplish that, what happens is essentially a secondary shader runs each frame. There's some math errors with that. But I feel like we need to get back to baseline performance. So we're going to do 3 to the 5th here. So we can see the frames per second is already starting to dip. So we're below 60 at just 1,600 things, which is not unreasonable. But if we add in the avoidance flows in similar, it becomes worse than this. And we really can't have that. Part of the problem is that when we're running the shader logic, we make the assumption that it's ready on the next frame. And that's not actually a safe assumption. If you guess correctly, everything is fine. If you guess incorrectly, one of two things happens. It can truncate the shader run. Since we're doing multiple parts, I believe that can get truncated. Alternately, it will require a stop and sync, which we're working at CPU and GPU speeds. It's not super duper slow, but it's way slower than we want it to be because we're effectively slowing the GPU way down anytime that happens. Again, by itself, Like in a vacuum, it's not a big number, but happening every frame, it becomes a big number. It becomes a problem. So 2,400 things, 42 frames a second, we're still within acceptable territory, but I think we need to do better. But breaking out of that pattern is going to require... Hey there, Lunar. Backrooms warehouse forklift operator job sim minigame. Not yet. Did you see that there's going to be a Backrooms movie? Unless that was April Fool's. It's hard to tell anymore. It used to be that April Fool's stuff was all very clearly like, haha, this is just a joke. It's obvious. But now you'll have, hey, here's this really cool idea. JK, we're not doing that. But yeah, apparently Backrooms movie. Seems interesting. There are a lot of these kind of what would I call it? Urban legend kind of things, like modern urban legends, that I think are well suited to something like a movie. A lot of times they don't translate well to games, actually, because they don't carry the same sort of atmosphere that you can get with a movie. A lot of times they end up kind of devolving into zaniness when they become a game. Whereas things like the Backrooms are more centered around things being surreal and unsettling. But when you have a bunch of people just kind of goofing off inside the setting, it removes any of that edge, and it becomes 4 people goofing around in a really bland setting. And there might be monsters. Okay, that's our save. We are going to add a short circuit into our add dispatch here. What the add dispatch does is add further to a shader chain to do that particular operation. I don't know that I've actually got that fully wired up, but let's validate our performance change here if it's present. Might have already excised that. But this does illustrate somewhat that we still have, it's slightly better right now because we already had damage being done by the collision shader. So we're at kind of better, but still not good enough. Let's go into our collision here. So this is where we start to run into problems, is we cannot do the collision shader in one go. The calculation that we're doing takes way too long, and the process will make it time out. And if that happens, you don't get all of the collisions. We ran into that by coincidence. Luckily, we caught it, but there were side effects to the way that it was handling the timeouts. So we've broken it way down here. We run in, I think, so we have 40 batches of 8 to the 3rd is what we're dealing with here. But these run sequentially, so it's even riskier to do the next physics frame. We don't want it to take much longer than that, though. But when we're dealing with just a submit, we don't really have control there. What we want to be able to do where is it? There is an async call that we can do. So that's get data async. Where are you? You can't use this where we are the way that we currently are. But here. No, we still can't do that. So this is where we're sitting right now, is that we want to be able to do this, but we also don't want it to be in a circumstance where we are reliant on it being the next physics frame. But this is a balancing act. This used to be a thing that you had to do, the barrier. This method does nothing. The barrier was a way to specify that a particular sequence was wait until everything prior to this is done. This pattern that we're setting up where we add these dispatches iteratively, or we set up the dispatches iteratively. Words and things is what you do with is how you set up the barriers now. Is I'm saying here is the pipeline, here is the uniform set, here is us saying this is effectively the package. Run through it accordingly. So each one of these gets handled sequentially, which is already a problem because we can't fully leverage the multiple cores async nature that we can get out of this otherwise. And part of that is due to this pattern here. We do about 512 different hits during this, and we need to be able to do 20,000. So we do that 40 times. So that's where we're running into problems with our compute. And this is why it's we're winging it day, because I don't really know how to get around this issue. We can't really say good enough at this point because we can't go beyond this limitation. Like, we can't add the avoidance shader. I want to add the avoidance shader, this part right here, and get that working, but it leads us down a road of things are going to potentially take too long. So we need a way around this. Or at least we need a way to mitigate some of these costs so that we aren't hanging as much on some of this computation. One thought is to change it so that instead of this linear sequence of invokes, is that we have a series of call and response tasks that we're going to do. is we will invoke one message and we're expecting a subsequent message, but any of them can appear. We're just saying, hey, we're doing game start. It's going to do the game start thing. Until the game start thing is done, which is entirely just a invoke. Let's go to that. All this does is invoke the message. What we would have is initiate this as a asynchronous message. And at the end, we're going to have some sort of it's done message. So, game start step done kind of stuff. Which is different than game steps done. In this case, there would be a game steps done would be a possibility. We're going to try to avoid that from a pattern naming convention. But each of these would be handled essentially as a await the result. Do the thing, await the result. Let the rest of the code continue as it will. Now, part of handling that would be... Let's go into our physics process here. Here. So this would not be constantly cycling. This would only cycle if we were in a we're ready for the next step state. Now, we're still going to be accumulating our time passed for the delta. And only once we have gotten back around to physics process again, as far as the state is concerned, would we emit the accumulated delta. And we can use that for the kind of basis level debugging here is the bigger this delta gets, the longer it is taking us to get through the whole rest of the process. Right now, delta is generally going to be between 1/30th and 1/120th of a second. We hard code it so that delta, as far as the rest of the program is concerned, that the time passed between steps is, I believe, about 1/60th of a second. It's defined somewhere. But we would still stagger that. So let's real quickly let's go through that step here. Hiding the screen so we don't blind everybody. Because by default, Paint starts with a white canvas. Is very, very bright. Oh, apparently in a future update, they're getting rid of these Copilot links on their basic apps. So Notepad and Paint and whatnot won't have Copilot buttons on them. It's almost like Microsoft realized that everybody hates this and is growing angry at them. And might want to change course before this whole thing collapses on their head. Okay, so right now we have... I feel like one of the big red flags for them was when they had a C-suite guy get up there and try to say, hey, stop calling us names. Okay, so right now what we have is a series of messages that go one after the other down the chain here. So we hit one of these messages. This goes out to something else. Any number of other entities might be waiting on that message, and they do their thing. And then we iterate down the chain. So what this does is it creates a effectively a fully linear sequence, a known linear sequence that when this fires, these fire, and then this next one fires, and other things fire. But all of that is a blocking series of events in the midst of the physics step. We don't actually need to block there. So the first stage is going to be breaking that out. So instead, we're going to hide that. We'll have our same thing again, which is our physics step. But what we'll have is really just one box. And we're going to say, fire this box, and then we cut this state. And our next one is, so this goes out, and this is going to do its big series of stuff. At the end of this series of stuff, we loop back around. But this is happening independently. So each one of these bars is a physics step. And here again, we are so during this whole time, we are waiting for this thing to finish up. Once it's done, we're no longer in that state. We fire it through again. That's not useful. There we go. But this is a whatever else is happening state. We don't care until we get back around here. So we've got to see if we can facilitate that for now. The starting point for this will be here. Async theory, we should do a task. Let's call it main loop for now. Ready, and then we do main loop, and that is entirely fire through those events. Hey, Denizen, welcome. How do we want to do this? Oh. Let's go find that pattern that is in our catalog that we're doing that. I am very locked in. I'm hoping. Hack cough. Hoping that we can get somewhere with this. Catalog. File reader. Was mentioning to somebody, one of the sad things about the way my cough works when it's fully agitated is laughing can set it off. So if it's the wrong kind of laugh, then I start to cough. It's readline async, which is a async task event. We could have it return a result here. Not this. It's not our read game data file. It's the whole thing, though. Okay, yeah. A task.run, an asynchronous method, which is this thing, which includes awaits on it. But that async can just be call that method. And then we're going to await the task when all done. But we're not doing them all at the same time. So we're going to await task.run with this. This will totally work. That is a main loop. We can't await in that. But we're not really doing that. Okay, we don't care about that, though. We want this to run independently. What we want this to do is fire and forget. Run this. Okay, so then we have... we have an accumulated delta hanging around here. If not waiting. Pass in the accumulated delta. And then accumulated delta is equal to 0. Okay, so each physics process, we let the root object do what it wants, and then we are going to keep a running tally. If we are not waiting, we become waiting, and we run the main loop, and we zero out accumulated delta. Now, for as long as this is running, we are going to keep building this up, but we don't run another loop. It's not until we get here that we're going to cycle back around. It's a vicious cycle. So I have to do sound test at the beginning of this because sometimes my noise canceling fails and the background noise comes through. And I left it on and, watched a funny video, forgetting that I had left it on, and I began coughing, and it sounds way worse on the stream. I'm not saying it doesn't sound bad in my ears, but yeah, you guys are definitely hearing worse than I hear. Okay, and this will totally work. It's not totally working. Okay, we are doing that thing. As of right now, that thing is happening. But, okay. This implies that this occurs. Yes. But we're not getting any of these cycles actually happening, which is weird. Default waiting is false, and we get into that. Why are you no working? Okay. It's about 1/60th of a second. Each time about 1/60th of a second. Oh, okay. Let's see if we can spot this. Okay, you can just barely see her tail. There is a face-off happening right now. I can tell that it started to happen because Ember was like uh, crying out over there, her tail lashing, and Sky doing that sort of like head back a little bit, staring right at her. Um, if you've if you watch cats with any frequency, that is generally the um, it might as well be two drunk guys like facing off with each other saying, "Come at me, bro." Oftentimes there will be a raised paw, and neither of them has swung yet. But yeah, Sky tried to face off with Ember, and generally it's when she's like napping or something like that that he can win. For some values of win, you know? We have a rare occurrence. Sherbet is across from the keyboard here. We need... Where's core? We were doing character creation and we had to get it just right. Is important. Okay, the accumulated delta should not matter. This is extraneous. This is actually handled in core. No, it's in game. We run that in game. Physics process. We weren't accumulating delta before. We were just passing it in. Okay, and that's handled elsewhere. What's the matter, you? Come here. Did you pick a fight and lose, sir? Yeah. This guy was running around crying. There are a few reasons that happens. Perhaps someday. Perhaps someday we will add more emotes. So in the world state is where we're actually accumulating the delta. Right here. We're accumulating the delta in addition over here in game because it is possible that this takes extra time. You're being a nuisance, bud. Yeah. This guy is being pouty. Said he lost a face off and now he is kind of halfway in mischief mode. I have a lot of zip strips holding things like the camera array together. And similar like bundles of wiring. And I intentionally leave the extent like the tail of the zip strip out instead of trimming it down, because he likes to chew those, and it distracts him from things that are more problematic if he chews them. Yeah. But why are we losing movement processing? That should be in player movement behavior. It's not a message. It is in... game, entity, behaviors, movement, move player. Okay, we are never getting that message, which is strange. Sticks is done. Okay, now we're invoking game time past. The primary usage of the Twitch points used to be our Noida integration. Once we also were streaming on YouTube, it was moved off of that into... Well, the Twitch points still worked, but there was like a parallel system in place where you could essentially buy impacts on the game. Eventually, it became you get tokens, essentially. In the game, whenever a viewer would show up, they would get a representation on screen. The little avatar in the center of the game that I'm using here is the same thing. Little catbot minion would appear. And you could use your accumulated points and whatnot to strengthen the player or upgrade your minion. Alternately, you could get a whole bunch of points at once if you blew up your minion. So you could essentially sacrifice them for an effect. And that had two impacts. One, you got big points, and people almost universally spent it on mayhem, orbital strikes, and what have you that were dangerous to the player. But additionally, a killed catbot had a side effect, which will show up in this game eventually. It's a if you know, you know. It shows up in some of the old Noida shorts. Okay, game time passed. We go in. Accumulated delta. Delta is 0. The what now? Well, that's a problem. Okay. Well, there's our issue, is time is not passing. Which is strange. Yes. Yes. Step in. That's why. Right there. That's why. Okay. By the time that runs, we have a problem. Let's see if we can fix that. Okay, accumulated delta is currently 1/60th. So we step over, we get in there. Delta to use is 1/60th. So we're going to step over here. We want to get here. We get to here. All right, we have our 1/60th now. Because this was running here, when we passed accumulated delta into it, when it executed, this was already 0. It's still not working. Why is it not working? Okay, move player is never getting called. We're never getting to main loop again. We're still waiting, and we're never getting to here. Okay. We're not waiting. We get to main loop. We get done with main loop. All the right stuff is occurring. We're not moving, though. And as soon as I tabbed over to this, it stopped completing that task. This has ceased. We stopped getting through that. So I viewed that, we activated it. Main loop is never getting called anymore. So how is that? How are we never getting to the end of this? Sit for a moment, stop here. Yeah. We could have a bailout, but that just leads us to the issue that this is a problem. Now, what we may need is a callback on this, and in fact, we should have a callback structure. Is when it is complete, we're not relying on a variable, we're relying on a particular method that will be invoked at the end. Now, why are we doing this? Because I want to see what the state of task is. It's called it's broken. That's what it's called. This local result is a nothing. That's extra weird. Okay, well, that's even more broken, and I'm not sure why that's more broken still, but it's probably because we've created something out of loop there. Okay, is there a variation on this? Is there a way for us to get a callback into this? Action, a function, a way to get the cancel token. Okay, we could just have it be a callback that we set up. Matter, Sky, huh? It's your own fault picking fights, sir. The only reason Sky ever gets to bully anybody is because Ember lets him. He tries to be big cat, and Ember just doesn't want to bother. But as we saw earlier, if she decides to face off with him, yeah, he can chase her around because he's bigger, but she is fiercer than he is. Ember is very non-confrontational normally. So one thing that we could do is encapsulate each of these into its own event. Like when we invoke it currently, we are saying, here's the sender and here's the message to use. We could, inside each of these, have them be a task, and that task calls the next one when it's done. So run this, call the next one, run this, call the next one, and divest this completely out of this loop here. Which creates the pseudo state process that we've got. Yeah. Let's do that. Today is going to be a lot of speculative coding. We may need to we are probably going to need to loop back with each of these. Okay, so right now it is start step, time passed, end step. So each of these will call into the next. Outlining, collapse definitions. There we go. So our invoke here. So what we'll do is we'll wrap this. We'll wrap the call to this as the start, or at least we'll wrap that first one as a task run. And the assumption will be is that once we get the final step in it that we're done processing, we can do that. Okay, so we're looking at game steps done. That is what we want to be able to react to here. It's not perfect. It's not perfect, but this will be a good start step here. So I'm going to get added to the tree. Go through all these emits. Steps done. Emits game steps done. Is equal to services dot resolve. This. That can be at the end. Okay, on game steps done, that is when waiting is equal to false. So then in our main loop here, that's not when waiting equals false. This is when it will trigger. And then the next physics process can go. How odd. Uh-oh. No. I have a feeling here. Yeah. Okay, we can do that cleaner. This is the thing that emits game steps done. I really should have an intermediary for that, but... All right, so in invoke game steps done, we'll just do it at the end here. Okay, part of this problem, I think, is that our... We're not computing. Next time, we should be computing. Part of the problem, I think, is that the rendering device is being created inside of a thread that is no longer active. So we get rendering device. We have a rendering device. We sync. So we get buffer data from the debug buffer. It has nothing in it. Get the debug values. Nothing in it. Okay, that's our problem, is that context is gone. We're now in a completely different thread. And we get it out of there. Okay, we need to get our rendering device manager. We'll hop into here so we can find it. When it is instantiated for the first time, we create a local rendering device. That gets us the first one. Then the entity buffer, unfortunately, we moved that out in a fashion that is probably going to cause us some problems here. Render device manager. Okay, where are we getting our buffer? Start step, world steps done, compute collisions. All right, we get that. Entity position buffer, okay. Shader buffer. And okay. We get the rendering device at the time that this is instantiated. And we set it up, but that means that it's when the services are created. What we're trying to do is make sure that all of this stuff exists in a way that we can get it in a subsequent thread, but I don't know that we can safely do that. But we don't have to. Okay. Okay, quick pause here. Be right back. And we're back. Okay. How much of this is because we are doing it at the top of the loop versus otherwise? But this sort of threading is where you get into this kind of trouble anyway. Because I don't want to extraneously do this. The only reason to do this operation is if it's necessary. And we need to get that data. Buffer isn't available at that time. Is the buffer available when we're actually doing this? So when we're in the midst of compute collisions. So we have a collider buffer right now. That is an entity that exists. But we don't know that all of it's going to survive this loop, because this whole operation exists within this particular execution. So it could be gone by the end of it, is the problem. But this is a rendering device that should already exist. We have a thing. As soon as this exists, this happens. But rendering device, does it exist yet? Have that, and we're going to look at our collision shader manager, and we're going to go to here. Okay, so this is now coming into existence within that task, within that other thread. We need it to come into existence sooner than that. We can short circuit it for the time being. Like I said, all of the things that we're doing right now, we're probably going to have to redo. This is all throw stuff at the wall. We're just calling that. And what that should do is this should happen. So right here, we're going to resolve it. As soon as we resolve it, it comes into existence. But we still get the out of bounds. Okay, so it exists outside of it. The rendering device is being created outside of that. But is the buffer now? So now we need to get the buffer logic here. Yeah, okay. Once again, we're just going to force it to happen. This should create both of them in the context of the main thread. Same problem. So this may be a dead end. We might be able to move this out into its own thing that is just kind of spinning in place, but we need to be real careful about having that kind of thing. Okay. So we're going to move this out of here. Instead of on game start step, we are going to move all of this right to the bottom of compute collisions. We are going to submit, then we're going to sync. This is bad. We should not do this. But we're going to do this. So then at the end, we're going to say computing is false. And because of compute collisions firing that way, will always just be this. And game start step will never do anything. This doesn't make sense. But maybe not. Because the entity position buffer that we're using might not be getting its updates properly. Okay, so we have a buffer update that happens. We get into compute collisions. Hey there, Jesse. Welcome. We're in kind of desperate measures optimization day here. Much of the code changes that I'm making are not going to be committed to branch. We're just hacking away here. Wait a minute. Oh. We don't have a buffer yet. Oh, well, we haven't gotten the buffer yet. Buffer exists. Okay. It's our output buffer. And this is created as a write-only buffer or read-only buffer in the code. Oh, collider buffer. There's nothing in the collider buffer. Okay. Data span that we have. Do the entity position buffer. So currently we are doing a buffer update whenever physics start happens. Can we short circuit this? Ugh. All right. Fine. Okay, this removes pretty much every bit of optimization we've got as far as the buffers. That should be okay. What we're doing here is saying make a buffer every time. This should make a new buffer for the purposes of that execution. But that buffer does not have... What? Come on now. Ah. Okay, we have data. We're getting our rendering device, which should be the same one. We create the buffer. Okay. It might just be that we can't get the data out of this one. Well, thanks for swinging through, Dennison. Ugh, why is this happening? This might be a dead-end optimization that we're dealing with here. Because we're getting nothing back is the problem. This is weird, though, that we submit. That should mean that when I do sync here, it's going to force it to connect up. There should be an output buffer set up, and that output buffer is of the size of the output buffer length. This is already a thing. Its output buffer is loaded up. So we call that, and we're getting nothing out of it. Okay. But when this is readied, when we load the collision manager, that's when we get the rendering device to create the shader information. So that thing exists outside of the thread as well. Well, let's purge our changes here. It's the fact that we're putting it in a task becomes a problem. Because that separates it out. There is now a different thing that holds that. If we can get it all in... Well, no, that still doesn't work. So we run here. Go to our on game start step. We're going to run to this. We get debug and we get the data. This is a known thing. The data inside that buffer should be an absolute thing, but we're running afoul of where we're creating them. So that buffer doesn't play nice with being inside of a task. And we can't guarantee that like trying to run that does anything. Trying to access the buffer might not do anything. Which puts us in the problem state here. We are going to do callable. There's a way to do this. Let me look that method up. I think this is a Godot object, so we should be able to do that from. Okay, we should be able to do that. Thank you. Oh, what do we gotta do? Should be a byte array. Yeah. Callbackle. Ugh. There we go. Does this ever happen? It does. Okay. This creates possibilities. We could move all of this into the callback. Here. We're not going to do anything with the debug buffer. We don't need to sync. We get all the way down here. We submit, and we say, get the data async. Nothing happens here. We do all that, and we can say, yes, it does. Device. No, it didn't. Can't move. Nothing is happening. Get all the way down here. Okay, the call is no longer happening. This should be extraneous, but, you know. Nope, never happening. Why is it never happening? A. So this was working before. No errors. Are we running into the same problem that by calling get data async, we are abruptly ending the call? I think that's what's happening. Oh, this is obnoxious. Okay, we're going to wait a little bit. So we just submitted it. In theory, this shader is running on the GPU. Nope. A non-trivial amount of data, but that doesn't help us. So this doesn't do anything. Unfortunate. Unfortunate. So we can't do an immediate sync. That will kill it. Well, let's... Not quite. All right, let's do that again. still nothing. It's that we're not getting to the end. We're getting truncated again. So we could be in the position that the shader, I think, is still too useful for the way that we're handling collision. There are just too many collisions that can happen that we would have to deal with. We could always fall back on everything is a circle, but that limits our ability to do any sort of collision that isn't a circle. If everything is a circle, then we can let Godot do area-based collision and have the layered areas again. But there are a lot of problems with that pattern. A lot of problems. But doing it this way requires that we have some period of time passing, which already puts us in an awkward position. We're already potentially losing physics frames to this. It is not out of the question to do that. But if we want to break that apart further by asyncing some of this stuff, we run into problems. Like, we would still have to do the physics stuff in sync with the actual physics process step. Which I don't know if that helps us. Let's refocus and let's target getting the time passed. Let's get this separated. So we have this step and then these subsequent steps. So we're going to break this apart. We have our pre-time passed and we have our post-time passed. All right, so let's get that in there. Because we need that to happen separately is the thing. There needs to be some sort of way to let it fall back to this thread. So we don't want it to just be an invoke call. It needs to be something we can await. This simpler then. Oh. We need these to happen after this happens. But they can't be in separate threads. They have to be something that happens in the physics thread. And we don't want to have to wait till each subsequent step in order to invoke them. This needs to happen after, and this needs to happen before. Can't do an await here because this is not an async function. Do time past message. Okay, and then we are going to call test with time passed. Basic flow generator is being caught up in this. We are in the midst of what here? All right, this is catching a time passed because we are trying to get this at the moment. But vector 4. And then here we're just going to return. Invoke game time passed, invoke world end step update position. Asyncing that seems to have been a problem. as before. Be the same problem that we just had earlier today, but yep. Okay. So same general issues that I was worried about. One, it's the rendering device does not play nice with async logic. It has to be within the threads that are provided to it in Godot. This is not out of the question. We could have all of that exist within the physics thread and still let it do its thing there. But we're going to have the state machine set up for it. Such that everything else needs to be able to happen outside of it. There is still risk surface with that, but since we require the sequence of events to say this has to happen, then this has to happen. So we should be able to submit those, wait for the next physics step. It calls out, you know, this is the next physics step. Yeah. So the physics handler is largely in the same fashion as it was. Do the checks, but we need to hand off during that. So we have 3 states is we are waiting for physics to come back. We have calculated physics and we're sending physics out. The last 2 are kind of the same state, but with there being the physics process tick that has to happen in between. We could... we have game start step that is called is when we are invoking that. Ugh. We're in a fiddly spot, folks. So again, the rendering device needs to live in one of the Godot threads. I don't think we can get it out of there. But I want to free it to do its thing. We need a couple of things. Is I would like a way to know that our physics processing is done. DJ, because I personally like using a vtuber model. It's less of a why and more of a just a true. I do. Hmm. What do we need to do for this? This would let us just wait a full physics tick. The first step is send it. That happens at the end of a physics step if we are done moving. passing. This model is is largely a reference to the kind of a personal story that built up with a prior game mod we made. The lore developed and took on a life. So start step gets caught and says, okay, that's when we are waiting for physics, but mostly it is the physics done that we've got here. So that is, where are you? Shader Collision Manager, I think, does our physics done. So that's invoke physics done. And the start, the physics loop over on this other side, we could have it waiting for physics done. And when it gets physics done, it kicks off the next iteration. And when that iteration is done, then we kick off the physics loop of it. But so that should let us desync that. But that's still game start step comes around. Okay. So in game, we have these three general steps. We need it's physics done. It's physics done. That's physics done. Dot physics done plus equals that, which is on physics done. When physics is done, we are no longer waiting for physics. In fact, we can just do a time passed at that point. We could be accumulating delta in here, and if we're not waiting for physics done, start step though, we're still just getting raw time passed every time this happens. It's only the world time pass that cares about that. I think that's okay then. So we don't need to pass the delta around. So we do a game start step here. When we get done with physics done over here, we can kick off the task that is game time passed. Private async void. Oh, we need the delta to be accumulated here. We need to be able to pass it along to time passed. We've got to get the states in here. So this is by default. This is true. This will be the first step that fires. Last time passed, and we will kick off the game start step at last time passed here. Then on physics done, that's where we invoke game time passed here. Still not perfect, but okay, so we will run game time passed as a independent task here when physics is complete. All right. Let's see here. Evoke this. But we don't want this inside of a task is the problem. There needs to be another trigger that happens that can break it out of this async. Can I do an async here? Await the time passed. And then we'll do the end step and the game steps done. So this will kick it off. If game steps are starting, we go through with this, and then we're saying game steps are starting again. As we're doing time passed, we're still running into this. All right, well, it's super choppy. The process is running pretty fast, but the simulation is running very slow. You can see the hitches going on here. And the flow generation is preventing that from working. The entities aren't being emitted. Everything is very wrong. Gonna do double increase the accumulated delta, and say accumulated delta is equal to 0 here. Get to that. Okay, the visuals of the entities are not updating right now. So you can see how the screen is shifting, but the player isn't. That means that the camera is tracking where the player is, but the player's sprite, despite moving around like visually shifting left and right like they are, is not having its position updated. So the actual motion of the player sprite is never updating. Oh, it's not computation, it's in rendering, entity rendering. That is just the base object. Entity visuals. For some on calls here. Are getting position updates. But they're not actually updating. Theory, if I go far enough down here, we should see. Here we can test. Time is not properly passing. No, it is. We can see this number is going up, but we're not getting entity visual updates. All right, we haven't been doing part of the testing flow here, and that's what kind of errors are being generated. A lot. Only be called from the render thread. Super cool. Okay. Okay, but we can do that now. So in the game loop right now, we are just using physics process, but we can use process over here. So in physics process, we're kicking it off. Isn't ideal. Yeah, if this is the route we have to go down, then great. But okay. Just gonna wrap this here. Then on the next render step. So we have game steps starting. We would set if false. If this route starts to work, then game steps ending, and all of these become part of a state machine instead. We have a series of objects that like control is handed off to. So this is game end step and game steps done. And game steps starting don't happen here. Instead, they happen at this part. What? Okay, each frame we're either going to be in one of these two states. This is not perfect. We only want these to be for when we're dealing with the physics shaders. Oh, that's still failing. Oh. Same thing. All of all of this stuff wants to be in the render thread. All of the physics logic wants to happen in the rendering thread. So this won't do either, but how do we deal with that? Because right now, since a lot of this stuff is happening in the physics thread, we aren't getting the opportunity to control it one way or the other. We could shunt all of this stuff off to our own threading and not care about Godot's physics thread. We could do our own pass of it and just constantly pass off. That does remove our ability to cleanly use the Godot physics tick, though, which would be kind of a shame. But we're already really far into the weeds as far as using a different infrastructure. Okay, so how would we go about doing this? That means that all of the shader logic would need to be broken out into its own kind of setup. But right now, the shader logic is watching for some of the stuff that happens on the physics step. So what if, instead of doing all of this in the physics tick, we first move it all the way over to the render tick? Everything's in the render tick. Is that great? No. But are we going to do it that way? Yes. Okay. So instead of this being here, we just move you on down to here. Things are running again. Entities are moving again. Thing is moving at a reasonable pace. Let's look at it from the Godot side and see if we've got the I don't like when you're doing this problem wrangled. Seems like it. Our frame rate isn't fantastic during this, though, because we are not utilizing that second thread versus rendering. Yeah, we can definitely see hitches happening. For this to be viable, okay, so what we benefit from here is that we have freed ourselves from the problem of the shaders complaining about when they're operating. But it means that we've put a lot of load on the rendering thread. And we don't want that. Can we break that apart? Let's find out. So what if we don't, like, process shouldn't be an async thing. Let's do... So we're going to fire off a task. We don't care when it gets done. So then it's if not running loop. Vid void a loop. This is going to be a time passed message, time passed. Say ask.run. Ah. Okay, we don't care. We're not awaiting this one. This doesn't need to be async here. This can be async, but it's not really a problem. So what we're trying to do with this is say, if we're not running the main loop yet, start running the main loop. And we're just going to run all this stuff. Don't update the debug there. We update the debug down here. Oh, we broke time again. Hey, Godot isn't screaming about anything in particular. Oh. If we're not running the loop, run the loop. Still problem. And then it stops happening. Once this doesn't happen, we're hosed. So there needs to be a... It's just wait one here. This is tricky. Change anything. So core problem, this gets lost. We want everything else to continue once I do this. And I don't want to wait for it here. I think we're probably going to have to dig at this a little bit more research-wise. Yeah. I think this will be a break point for today. It's effectively what we're looking at right now is, since the shaders are successful, but it doesn't like to have them on the off of the render thread, we're running into some problems there. If we put them on the render thread, that breaks the whole flow we're dealing with. If I try to update the buffers and the buffers are created on the render thread, then it doesn't like that. But if I move it all to the rendering thread, then we're losing the benefits of having two different threads running. We can do that, but that creates the problem that I have two different things running at the same time now. Like, I would have to do the threading myself, which is a risk surface. We'll have to see. We'll have to see. But for the time being, we'll wrap up there. Well, I hope everybody had fun watching today. A lot of just trying to make it work. Not ideal, but sometimes that's how it's got to be. Potentially, we're going to have to make concessions about the number of things that we can have present. Scale back. I think we could safely crop down to like 3,000 things and have a fail case there. But I really would like to have enough room that even if things go completely out of control, that we can still handle it when it happens. But even right now, we're not really handling it. So we'll have to dig at that further. All right, though. I'm going to wrap up there for the day. And I'm in a conversational loop here. Well, if you like what you saw and would like to see more, remember to like, follow, subscribe. All those buttons are generally good, and I'd appreciate it if you press them. Next thread is stream is probably going to be gaming. We'll probably do at least one more stream of Monster Hunter Stories. If that keeps picking up and keeps holding attention, we'll keep doing that. Otherwise, we're going to shift on to some detective games. It's all going to depend on how things go. But once again, I hope the rest of your day is good, and I'll see you next time.